This session is about big data, so if you come here for regulation, this is not the session, it's big data. We have lined up a fantastic line of speakers. We have some of the worldwide's biggest thinkers on this subject brought together for you.
I think what we're going to be talking about this afternoon is pretty close as you can get to magic, at least in 2011. What if you could go into any store or a store and they could know, just as you walked in the door, what you wanted to buy, what you might want to buy? What if that was possible? What if you could ask any question, or almost any question, and get the answer immediately? A little bit like the Wizard of Oz. What if that was possible? You know, I think all of us intuitively feel that today the products and services available to us really don't make use of that data. So I'm just going to look very quickly at the financial life of a young fictional man called Henry Dorset Case, who was born in 2004. His credit is, you know, in real time using massive analytics on data streams of his whole life stream is captured, is understanding and dynamically predicting what his credit risk is for any certain amount of credit. Everybody knows that Henry's going to die between his 76th and 82nd birthday because he had a blood test, and genetically that's when he's programmed to expire. Using very, very intelligent technology, analytics, and massive data source to give him relevant, actionable information in real time, and allowing him the freedom to focus on his life.
The use of big data is going to be a key basis of competition going forward for firms, for sectors, and for economies. Over the past 25 years, the types of data we're generating have changed dramatically from nearly all analog to nearly all digital. It matters for the financial services industry, because in this industry, the factory is the data center. The average company has more data than the US Library of Congress. Big data can actually be a tremendous enabler for individuals. So whether or not it's individuals trying to figure out pricing, or it's individuals trying to understand their health better. Changes in the way that organizations are able to measure can often change the way in which they create value. Just making things transparent can provide a tremendous amount of efficiency gains. Companies are starting to understand how to do experiments and change the way they make management decisions. Not only do you need those deep analytical people, but you need to change the mindsets and skills of the people who are going to be consumers of that big data analysis.
Computational capability has really enabled a lot of things in our markets, especially the whole derivatives market as an example. We need a whole new set of technologies and a whole new way of dealing with this type of information. We need to be able to do what we call as listen, is to be able to capture that information, normalize it, and really store it. So you can start to really work with and store it in a way that you can start to run a lot of models on. And once you're able to do that, you can really start to do some predictive work. Zynga is an excellent example of how big data is changing the gaming market. Blue Crest is a hedge fund based in London. They manage almost $25 billion of assets. They take all sorts of financial news feeds, Twitter feeds, and other type feeds to figure out what's going on in the market. You want to be able to do is, regardless of the channel, you want to know exactly what that user was doing. And that's, I think, one of the big benefits here. Compliance is going to be a big issue. As we get more and more into social media and, out somewhere, put your camera up, look at something, and it'll recognize, it'll know where you are, it'll know your user preferences, and based on that, it can do something to that whole environment.
The question is, how? You have billions and billions of rows of data already trapped around the enterprise. You got the blue puzzle pieces over there. You got the yellow puzzle pieces over there. And this piece of data arrives. Think about the way people put puzzles together today, and it helps me improve my algorithms. Picture this for a moment. Giant pile of puzzle pieces. You don't know if it's one puzzle, 5 puzzles, or 500 puzzles. There are pieces missing. There are pieces that are duplicate. Some of the pieces are professionally fabricated lies. Only until you start to bring these puzzle pieces together to see how they relate does the picture actually begin to unfold. The slowest piece when you put a puzzle together is when it puffs out and takes up the most room. But there's a point when you're doing this that it begins to collapse. You get the edges and the chunks start to fall in. That happens in the real world. It turns out the more data you get and weave together, your false positives go down, your false negatives go down. That means the quality of your predictions improve. Why is it when you search Google and it says, did you mean this? They're not looking at a reference set. They're remembering people's errors. If they didn't remember the errors, it wouldn't be so smart. The third and final of my big data new physics principles is the more data you have, and the puzzle begins to puff out, and then it begins to expand, you actually need less CPU, despite the fact the number of pieces of data you have is on the increase.
A lot of the regulations, like I said, really focuses on data and on ad hoc querying of that data. Analytics, right? No new data. It's all about just getting information out of the data that you already have. Instruments department and within equities, and we have our loan department making, creating some exposure to a counterparty. And at some point, that counterparty is in risk of default. And now we have to aggregate all that information across all the different silos in different models. Large distributed aggregation of loosely structured data, often incompatible and inaccessible. Semantic technology, something that actually allows you to take unstructured data and classify it. We're starting to see this notion of on-demand analytics. So we want to actually have fresh data, whether it's in our data warehouse, whether it's in our distributed data.
People inside teams I'm working on who are using Twitter feeds to look at sentiment analysis and correlate that with where the market is going to open. This is all about turning signal into value. So in my mind, much of this is about insight and sense making, and doing it over a broader spectrum. You all have tremendous amounts of ambient data. Your ability to derive new value is going to increasingly become the difference between being viable and not.
And that's what we did for the Swift index. And here, it's a pragmatic example of using a huge set of data, refining it, right, and then trying to see if there is a match between two different sets of data originating from totally different organizations, totally different purposes. We noticed that actually Swift traffic information was a good mirror of the economic indicator, so the GDP evolution in this case. And we also tested the predictive power. We will make also the information about the Swift index available to, as we said, to everyone.
So first is, there is no such thing as clean data. The second is that power derives from the combining of data sets. I think next is that visualization is a very powerful way to explore hypotheses. Once you've got a hypothesis, this is where the data science comes in. You want to test that hypothesis. The goal is to have a model that will predict the future, predict future observations that you haven't yet seen. The other quote that I like, that I think is relevant for this group, is Walt Wriston once said that soon information about money will be more valuable than money itself. This exponential explosion of data leads to the matrix. And I really believe there is a shadow world that all of us are walking around in. The goal of predictive analytics is to take these mountains of data and distill them down into mathematical models which can ultimately predict something about what might happen. Your data is sexy. Hal Varian said that the sexy profession of the next decade will be statisticians. And here, stop throwing away customer data. I cannot believe how many times I go into organizations and I find out that, oh, we only store 30 days of that customer data. Banks have incredibly rich social graph data. You understand who people are exchanging money with.
I'm a hardcore intelligence and counterintelligence guy. One of the challenges that I unfortunately I didn't hear here before is not about how to acquire the data and how to look at the data, but how to disseminate the data. Because while we are using the same data, all of us, the data means something different to you and to me. The only technology that can actually bring the solution to the user, bring the solution, bring some value, bring the context, as Jeff keep on saying, is a technology called semantics. You asked the question how much data we actually look a day. So the numbers are staggering. We are looking at 2.5 quintillion data sets a day. This is what the intelligence service is actually looking at every day in terms of information. For example, on Facebook, which everyone knows Facebook, there is 175 million new videos and images coming every 30 days. We're saying that for every piece of information, we basically have 1,000 more that are actually following it. How we understand the world, how we understand the financial markets, how we understand the transactional market is relatively, we haven't even touched the iceberg on what we have to do for the customer is separate those voices from noises, is to create a colorful picture for him from many, many scales of gray.
Whoa!